Alright, this will be our first video in Chapter 1, and this is Section 1 for Dual Credit College Algebra. And this section is actually going to be broken into two different parts, so this is the first video of the two parts. And tonight we'll cover basic terminology, solving linear equations, and the identities. Alright, this first slide just states what an equation is, and that's a statement that says that two expressions are equal. And to solve one of those, that's to isolate the variable, and that means to get all of the numbers or solutions that satisfy that equation. Sometimes there's one, sometimes there's more than one, and we'll be going through that as we study this chapter. So there are several words you can read over and write down if you feel the need to. Next, we want to talk about the addition and multiplication properties of equality. The first is the addition, and that property just states that if I add a number to one side of the equation, I also do it to the other side of the equation. That way I haven't changed the solutions that when I do so. And it works the same way with multiplication, we'll see on the next slide. And that says that I can multiply both sides of the equation by the same number without changing the solution set also. So those are things that you should already know. You're just refreshing your memory and letting you see them in a more mathematical like fashion than you might be used to. In this section we will focus on linear equations in one variable, and those are equations that have this form where a and b are real numbers, where a is not 0, and so we only have a single variable that is x normally, but it can be represented by other variables. But the idea is that there's only one variable in that equation. Something that we do need to be able to do, and we may not be able to, or may not be familiar with, is to be able to identify an equation as linear or something else just by looking at that equation. And I can do that in a situation and tell whether something's linear or not, because linear equations are also called first degree equations, meaning that your variable's greatest exponent is 1. And so in each of these top equations, the largest exponent on my variable is always 1. Whereas here, I have an exponent really of 1/2. I have a negative exponent here. My highest exponent here is 2. So these bottom three would not be linear equations. They would be other ones that we'll be more familiar with as we move throughout the year. And so we need to be able to easily identify equations as linear or not just based on their degree. Alright, now we'll actually move into solving some linear equations. And this first one especially is something that you have done many times since you were first introduced to algebra. And so remember, to solve it, we just want to isolate the variable, and the variable in this case is x. And so the first thing I need to do is distribute on the left side the 3, and on the right side I need to distribute the negative symbol. So we'll do that in just a moment. So after distributing, I have the resulting equation, and now I need to just clean each side up if I can. This side I can't do anything with. Over here I can put together the 7 and the -5. And so the resulting equation now, after combining like terms on the right hand side, is this one we have here. And so now what I'd want to do is move this x over here by adding, and move the -12 to the other side by adding. And so I'll do that now. And now the only thing I have left to do is to get rid of the 7 next to the x, and I do that by division, because that is the inverse operation of multiplication. And so dividing both sides by 7, I get a solution of x equals 2. It is always a good idea to check your solution in your original equation. That way you know you've done it correctly or not. And so I'm going to show you how to do that with this first one. So all I've done is written my original equation, and I had a solution of x equals 2. So what I want to do is replace each x here with that 2, and see if I end up with this side of the equation equaling this side of the equation. And there's a way to quickly do this with your calculator using the store function for x, and I can show you that in class tomorrow. For now, I'll do it by hand. So what I've done here is replace the x with the 2, and now I'll just simplify each side using order of operations and see if I get one side equal to the other side. And I should really have a question mark there because I'm not sure yet if those are equivalent expressions on either side of the equal sign. Quickly doing some calculations on either side, I find that it's equal to 0. Now you don't have to come up with 0 equals 0. You could have come up with 2 equals 2. As long as this side is equal to this side, I know that my solution is correct. So the solution to my original equation is x equals 2. Now here it is necessary sometimes to get rid of fractions before solving the linear equation, and so we're going to do that first in this situation. So what I need to do is determine by looking at each denominator what's the smallest number that each of these numbers will divide into. And after I do that, and in this case it's 12, then I'm going to multiply through by 12. Alright, so multiplying through by 12, this first component, 12 times 2t plus 4 divided by 3, will become 4. 12 is, and 3 is going to reduce to 4, times 2t plus 4. Now I'm going to do 12 times 1/2 of t, and that's going to become 6t. Next will be 12 times 1/4 t, which will make 3t. And last, we'll do 12 times negative 7/3, which will make negative 28. So now as you can see, once we multiply through by the 12, all our fractions are gone, and this becomes an equation much like the one we just solved a moment ago. So we would need to distribute the 4, and then combine like terms on this side, get my variable on one side and my constant on the other to get t isolated for the solution. And so I'm going to work that out now. So I distributed the 4 to the 2t and the plus 4. That's how I got this. Now I'm going to put the 8t and the 6t together on the left hand side. So now I have 14t plus 16 equals 3t minus 28. Now I need to subtract 3t and then subtract 16. So I'll have my t's on the left hand side and my constant on the other. And my result is t is equal to negative 4. And I'm not going to take the time to check that by hand, but I will show you again in class to do it in the calculator. Now we need to talk about some special cases when solving linear equations, and the first of which is identity. And that's when I end up with one side of the equation as equal to the other side of the equation exactly. So if I were to continue this equation, it would end up looking like this. And so when that happens, this is called an identity equation again, and that just means that any number that I choose to be x will work out and cause this to have a solution. And so when this happens, we say that the solution is all real numbers. The next is called a conditional equation, and that's the kind we see most often, where when I end up solving this equation by dividing by 2, I get only one solution. And that's the only number that will cause this equation to be true, and those are called conditional equations. And then lastly, sometimes I get equations that have no solution, and that's called a contradiction. Because if I were to continue this equation, I would get 0 is equal to 1, and I know that 0 is not equal to 1, and therefore this is a contradiction equation that has no solution. Alright, now there are 3 problems remaining. Here's the first. And I would like for you to complete these and bring these to class with you tomorrow. And that's how we will begin class, with you determining which of these 3 is the 3 different types we've just discussed. So identity, conditional, or contradiction. So here's your first one. Go ahead and write that down. Here is the second. Again, solve and determine if this is an identity, conditional, or contradiction. And then here's the last. And so again, please bring those with you to class tomorrow, in addition to the notes that you've taken with the video.